Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is your instructor Anisa Nawaz from Department of Physics. I welcome you all on this forum of online teaching and learning. This is our second lecture related to chapter number 1, measurements. In the previous lecture we have studied about importance of physics, importance of measurements, physical quantities, international system of units, base units, derived units and supplementary units. We have not discussed in detail about supplementary units, so in this lecture we will study about supplementary units in detail, scientific notation and some conventions for using SI units. We have discussed this thing that physical quantities are those quantities which can be measured or quantified. We have discussed about base physical quantities as well as derived physical quantities. We are yet having another class of physical quantities which are two purely geometrical quantities which are not yet classified as base or derived quantities. First one is plane angle, a physical quantity plane angle which is having unit of radian and symbol RAD. Second physical quantity is solid angle which is having unit steradian and symbol SR. So those units which are not included either in base units or derived units are called supplementary units. These are the units of plane angle and solid angle. So supplementary units include two units, radian and steradian, which are not yet classified under base or derived units by System International. So what is radian basically? It is the plane angle subtended at the center of the circle by an arc of length equal to the radius of the circle is called radian. Okay, you can see a circle over here. Any part of this circle is known as arc of that circle. If we are taking length of the arc equal to the radius of the circle, then angle will be equal to 1 radian. Radian is the unit of plane angle, which is basically two-dimensional angle. So let's illustrate this thing that what is a radian. If we are considering a circle of radius r and if we are taking an arc length equal to the length of this radius, we are taking this arc length equal to the length of this radius, then angle subtended will be 1 radian. If we are going to increase the length of the arc equal to the 2 radii, then angle subtended at the center will also be doubled. So we will say that if arc length is equal to 2 radii, then angle subtended at the center will be equal to 2 radians. If arc length is equal to 3 radii, then we will be having angle subtended at the center which is equal to 3 radians. If we are increasing the arc length equal to the 4 radii, then angle subtended will be equal to 4 radians. Similarly, if we are going to increase the arc length by 1 unit, then angle subtended at the center will also be increased by 1 unit in radians. So if arc length is equal to 5 radii, angle subtended will be 5 radians. Now if arc length is equal to 6 radii, then angle subtended at the center will be 6 radians. As we know that one complete circle is having 1 revolution, and while studying angles we know that one complete circle having 1 revolution is equal to 2 pi. So we say that 1 revolution is equal to 2 pi radians. Pi is a number having numeric value of 3.14. So we will say that one circle is having approximately 6.283 radians. So radian is a unit of measuring angle, a two-dimensional angle. What is a two-dimensional surface which is having no height? It is just lying in a plane, just like a disk. So as we have discussed this thing that a radian is the unit of plane angle. So plane angle is the angle between two intersecting straight lines measured in the plane of the same lines. Normally the angles which we are drawing on the page or which we are considering in geometry or mathematics is a plane angle. What is the formula of a radian? If we have to measure angle in radians, that will be equal to length of arc divided by the radius of that particular circle. We can divide length of the arc, which is represented by S, and radius of the circle, which is represented by small r. This is equal to theta. Angle is equal to length of arc divided by radius of the circle. So we can say S is equal to r theta. So if we are considering the relation theta is equal to S by r, over here S is the length of arc, r is the length of radius. Both are lengths, and if we are dividing these two lengths, then it will be the ratio between two similar quantities. So that will simply give us a number. This number is usually called pi. So how we can define pi, the number? We can define pi as the circumference of a circle divided by the diameter of the same circle. So pi is defined as circumference of a circle divided by the diameter of the same circle. How we are going to prove it? If we are having the relation theta is equal to S by r. S will be complete circumference of the circle, so we will put it as 2 pi r, and we have to divide it by the diameter of the same circle, so we are going to write it as 2 pi r divided by 2r. 2r will be cancelled with 2r, that will give you pi. So the definition of pi is justified over here. If we are going to divide circumference of a circle by diameter of that circle, that will give you the number pi. So according to the definition of radian, the angle subtended by the circumference at the center of the circle is either 2 pi radians or 360 degrees or 1 revolution. If we are taking any arc length for a circle, if we are taking any arc length, if we are considering the formula theta is equal to S over r, where S is equal to arc length of the circle, r is equal to radius of that circle. By the definition of radian, when S is equal to r, arc length is equal to radius, then from equation 1 we get theta is equal to 1 radian. Because S will be cancelled by r, both these quantities will be equal, we will get theta is equal to 1 radian. Again, the definition of radian is justified over here. But if we are considering the arc length equal to the circumference of the circle, then what we will do, for a complete circle, we are having circumference of the circle equal to 2 pi r. We will take arc length S is equal to 2 pi r, where r is the radius of that circle. Equation 1, theta is equal to S by r, will now become 2 pi r divided by r. We will get 2 pi r divided by r, that will be r will be cancelled, and we will get answer as 2 pi. So theta is equal to 2 pi radians for a complete circle by the definition of a radian. If we are considering arc length equal to the complete circumference of a circle, we will get theta is equal to 2 pi radians. Hence we can say that one complete circle is having 2 pi radians. So over here we can illustrate this thing that if we are considering a circle of radius small r and we are taking an arc length equal to the length of the radius of the circle, then angle subtended at the center will be equal to 1 radian. As we know that if arc length is doubled, theta will be 2 radian, 3 radians, up to so on. A semicircle is having pi radians and a complete circle is having 2 pi radians. Okay, so we say that if we are having a complete circle, then angle subtended at the center will be equal to the 2 pi radians. Okay, so we are having some other units of measuring angles. We are now discussing the angle which is in radian, and if we are going to measure the angle in degrees, degree can be defined as angle subtended at the center of a circle by an arc of length 1 by 360 of the circumference of a circle. It means that one complete circle is having 360 degrees and 1 degree is angle subtended at the center of a circle by an arc of length 1 by 360 of the circumference of the circle. Second is minute. Minute is another unit of measuring angle, and a minute is 1 by 60th part of a degree, a smaller unit. Second, yet another smaller unit, a second is 1 by 60 of a minute. It is 60th part of a minute. But if we are comparing degree and radian, then a radian will be a bigger unit. If we have to find out the relation between degree and radian, we know that for a complete circle, one revolution is equal to 2 pi radians, which is equal to 360 degrees. So we can say that 2 pi radians is equal to 360 degrees. If we are dividing both sides with 2 pi, we will get 1 radian is equal to 360 divided by 2 pi. Pi is a number having value 3.14. So we can say that 1 radian is equal to 57.3 degrees. So that is the relation between degrees and radians. That is the important relation. 1 radian is equal to 57.3 degrees. You can see here that radian is a bigger unit of measuring angle. 1 radian is equal to 57.3 degrees. So this is 1 degree and this is 1 radian. Quite a bigger unit than degrees. Okay. So if we are going to discuss the second supplementary unit, steradian, which is the unit of solid angle, 3-dimensional angle. It is defined as the angle subtended at the center of sphere by an area of its surface equal to square of radius of that sphere is called 1 steradian. In this definition, we are considering two things. First one, we have to consider a 3-dimensional surface. 3-dimensional sphere basically means 3-dimensional surface is such a surface which is having height as well. It is having height as well, just like a ball. So if we are considering a ball, and on that ball or on that sphere we are considering a surface area which is having area equal to r square, then angle subtended at the center, this angle which is considered over here, it is basically a 3-dimensional angle, that will be equal to 1 steradian. Okay, so as steradian is the unit of solid angle, so let's define solid angle. It is a 3-dimensional angle subtended by any object at a certain point in 3D space. You can see over here we are having this angle which is a solid angle, a 3-dimensional angle. Okay, so if we are going to consider a sphere, you can see a sphere is here just like a ball, and we are considering a surface area on that sphere. This red spot is indicating the surface area. This is having area equal to r square. Then we are cutting a slice out of this sphere. That angle subtended at the center will give you 1 steradian. Just like we are taking out a slice from a watermelon and we are taking that solid angle, 3-dimensional angle at the center, that will give you a solid angle. Okay, so some examples related to this solid angle or steradian, you can consider this: a birthday hat, that will give you a solid angle. Torchlight, again a solid angle. Some vegetables like carrot, it is also giving you a solid angle. Okay, If you are going to consider the formula of steradian, that will give you solid angle is equal to surface area divided by radius of the sphere square. So in radian we have considered this thing, that surface area divided by radius of the circle. Over here we have to take surface area divided by radius of the sphere square. So we can say that phi is equal to r square, because by the definition of steradian we have considered surface area equal to r square, and we are going to divide a radius of the sphere square. So we will get r square divided by r square. Solid angle will be equal to 1 steradian over here by the definition of steradian. Okay, so over here if we are considering the complete sphere, we can use the formula solid angle is equal to surface area divided by radius of the sphere square. We know that for a complete sphere, surface area is equal to 4 pi r square. Surface area for a sphere is 4 pi r square. We have to put this surface area in the formula. We will get solid angle is equal to 4 pi r square divided by r square. This r square is cancelled with r square. We will get solid angle is equal to 4 pi. So for a complete sphere we are having 4 pi steradians. You can recall that for complete circle we are having 2 pi radians, and for complete sphere we are having 4 pi steradians by using the formula of plane angle and solid angle. So any closed surface subtends a solid angle of 4 pi steradian at any of its interior point. So we can say that it is not necessary that we are having a spherical surface. A three-dimensional surface may or may not be a sphere. It could be any three-dimensional surface, any closed surface that will subtend a solid angle of 4 pi steradians at any of its interior points. Okay, so we say that we have discussed over here in this discussion about radian and steradian. 1 radian was equal to 57.3 degrees. Angle in radian is having formula length of arc divided by radius of the circle, and we have proved this thing that theta is equal to 2 pi radians for a complete circle. And in steradians we have discussed this thing, formula of solid angle is equal to surface area divided by radius of the sphere square, and a complete sphere has 4 pi steradians. Okay, so next if we have to discuss about scientific notation. What is scientific notation? Writing numbers in power of 10 or standard form m multiplied by 10 raised to power p is called scientific notation. There must be only one non-zero digit to the left of a decimal point. So scientific notation is such a notation in which left of a decimal point there should be only one non-zero digit, and we have to multiply it with some power of 10. That will be the standard form. For example, if we are having the number 123.4, that should be written as 1.234 multiplied by 10 raised to power 2, one non-zero digit before the decimal multiplied by some power of 10. That is the standard form. And if we are having the number 0.001234, that should be written as 1.234 into 10 raised to power minus 3. Again, one non-zero digit before decimal. It is a representation in the standard form. Why scientific notation is needed? Because in physics as well as in other sciences, we have to make very small or very large calculations sometimes. For example, if we have to measure the size of an atom, that is extremely small calculation, extremely small value. And if we have to measure size of the galaxy, that will be extremely large value. That will be having a lot of numbers of zeros. So instead of writing it as 0000 something, we can write it in the form of scientific notation to make the calculations more easy and more simple. We are having some positive powers of 10 and some negative powers of 10. If we are having simply 10, 1 0, then we can write 10 as 10 raised to power 1. If we are having 2 zeros after 1, we can write it as 10 raised to power 2. If we are having 3 zeros after 1, we can write it as 10 raised to power 3. 4 zeros after 1, that will give you 10 raised to power 4, up to so on. For negative powers of 10, if we are having 10 raised to power minus 1, that will give you 1 divided by 10. 1 0 in the division, that is equal to 0.1. If we are having 10 raised to power minus 2, that will be 2 zeros in division, 0.01. If we are having 3 10 raised to power minus 3, then we are having 3 zeros in division, that will give you 0.001. 4 10 raised to power minus 4, that will give you 4 zeros in division, 0.0001. You can see over here, if we are having 4 positive powers, then decimal is after 4 zeros after 1, and if we are having minus 4, then decimal is before, it is 4 points before this 1. Okay, so if we have to move the decimal to convert any number into the scientific notation, then we have to move decimal point right or left to arrange one digit to the left of decimal point, and we have to add some 10 raised to power any number. Okay, so if we, for example, if we are considering a number which is given over here, we have to move the decimal to the place, we have to move decimal left 4 places. Decimal is right now present over here after 4, so we have to move decimal left 4 places, 1 2 3 4, so that right now it is having one non-zero digit before the decimal. So number will become 5.2314 multiplied by 10 raised to power 4, because we have moved the decimal 4 points to the left. If we are having 3.2, then there is no need to move, and we will write it as 3.2 into 10 raised to power 0. If we are having number 0.0000428, then we have to move the decimal right 5 places to make one non-zero digit before the decimal point. So this number will become 4.28 into 10 raised to power minus 5. Minus 5 means that we have to move the decimal 5 places to the left over here to make this number again. Okay, so if we are having this number 602000000, so we have to make one non-zero digit before the decimal. We will move the decimal 1 2 3 4 5 6 7 and 8 places to the left. So we will write it as 6.02 into 10 raised to power 8. So we can convert any number into the scientific notation to make it more simpler. Okay, so there are certain specific powers of 10 which have been given special names and symbols and are frequently used in measurements. For simplicity, we have given some powers of 10 some special names which are known as prefixes of powers of 10. You can see over here, we are having some prefixes given over here. You can see we are having atto, which is having symbol small a, which is equivalent to the 10 raised to power minus 18. So instead of writing 10 raised to power minus 18, we can write small a. Instead of writing 10 raised to power minus 15, we can write femto or small f. So instead of writing 10 raised to power minus 12, we can use prefix pico, which is having symbol small p. Nano, small n, 10 raised to power minus 9. Micro, 10 raised to power minus 6. Milli, small m, 10 raised to power minus 3. Centi, small c, 10 raised to power minus 2. Deci, small d, 10 raised to power minus 1. Deca, da, 10 raised to power 1. Kilo, small k, 10 raised to power 3. Mega, capital M, 10 raised to the power 6, giga, capital G, 10 raised to the power 9, tera, capital T, 10 raised to the power 12, peta, capital P, 10 raised to the power 15, exa, capital E, 10 raised to the power 18. So these are the prefixes which can be used instead of some powers of 10. Okay, so while we are writing units, we have to follow some rules, we have to follow some conventions for indicating units. Use of SI units requires special care, more particularly in writing prefixes. Some conventions are used for this purpose, some rules which we must follow while writing the units. Let's discuss some of them. If we are having full name of the unit, that does not begin with a capital letter even if named after a scientist. It should always start with small letter. Like if we have to write the unit of force, Newton, in its full form, then even if it is the name of the scientist, it will start with small n. Newton with small n. Pascal, small p. Joule with small j. All these are names of the scientist. Still, if we are using them as units, we have to begin them with small letter. Symbol of unit named after a scientist name has initial capital letter. For example, N for Newton, PA for Pascal, HZ for Hertz, and capital J for Joule. So full name begins with small letter, but symbol is written with capital letter. Okay, so if we have to write prefix before unit, it is written without any space. For example, if you are writing centimeter, then centi and meter are written without any space. Micrometer without any space, millimeter without any space, nanometer without any space. So if we are using prefixes before any unit, those will be written without any space. But if we are writing the combination of unit, that is written each with one space apart. For example, if we are writing unit of torque, Newton meter, Newton is a derived unit, meter is a base unit, they should be written one space apart. Coulomb second, again there should be one space between these two units. Meter second, there should be one space between these two units. Compound prefixes are not allowed, which means that if we have to write a bigger number, so instead of writing a prefix 2 times like kilo ohm, they can be written as mega ohm. Microfarad is written as picofarad. Also 2 into 10 raised to the power 5 centimeter. Instead of using 10 raised to the power 5 with centi, we can use 2 into 10 raised to the power 3 meters. When a multiple of base unit is raised to a power, power is applied to the whole multiple. For example, if we are writing 1 kilometer square, square is not only applied on meter, but it is also applied on kilo. So it is equal to basically 1 kilo square meter square. It is not only 10 raised to the power 3, but it is 10 raised to the power 3 square, which will give you 10 raised to the power 6. So we say that when a multiple of base unit is raised to a power, power is applied to the whole multiple. And the last one, that we must use most convenient and appropriate unit. For example, if we are going to measure the mass, that cannot be measured in meters or kilometers, that should be measured in grams or kilograms, the most appropriate and convenient unit. Okay, similarly, length cannot be measured in Tesla or candela. Length is always measured in meter, kilometer, inches, or some appropriate unit. So these all points should be taken care of. So I would like to end my lecture with this quote of Max Planck: when you change the way you look at things, the things you look at change. Like if you are going to look the things in just to memorize them, just in a boring way, those things will appear boring to you people. But if you will clear your concept, if you will listen to the lecture again and again to clear your concept, then what will happen? The things you look at will be changed. Okay girls, that was all for today's lecture. Thank you so much.